Hey there, class. Mr. Bosky here. Hope you're having a good day so far. Today is 1.7 in Introduction to Functions. Our central question is, what is a function and how do we tell if data has a function or relationship? So we have a warm-up which is from 1.4, which is, it says, are the following values solutions to the given equation or inequality? Go ahead and try these on your own. All right, welcome back. So we have x squared plus 3 equals 7. We're taking this 2. We're going to plug it in for what? Plug it in for x. So we're going to do 2 squared plus 3 equals 7. We can do parentheses if we want. What is, now do we do 2 squared or do we add 3 next? Does exponents come first or addition in PEMDAS? PEMDAS. Exponents come first. 2 squared is going to be 4 plus 3 equals 7. And what's 4 plus 3? Does 7 equal 7? What do you guys think? It does. Is this a solution or no? This is a solution because it's true. Okay, just a throwback to the last couple chapters here. All right, next one. 2x minus 5. Actually, I'll give you a second to write that down. Sorry. 2x minus 5 is less than or equal to 1, and our value we're plugging in is 3. We're going to replace this 3, or this x with the 3. So we have 2 times 3 minus 5 is less than or equal to 1. Now, do we do 2 times 3 or 3 minus 5 next? What comes first in PEMDAS, multiplication or subtraction? Multiplication comes first. 2 times 3 is 6. Minus 5 is less than or equal to 1. Now, what is 6 minus 5 going to be? It's 1. Is 1 less than or equal to 1? Is it 1 less than 1? No. Is it equal to 1? Yes. So is that a solution or not? It is a solution. It needs to be one or the other. That's all it needs to be. And there we go. All right. Talking about functions today. You guys heard the word function before? A function is a rule. It's a what? A rule that establishes a relationship. A what? A relationship. Remember, when I say a what, you repeat the word after me. It's a good way to stay engaged with this stuff. A relationship between two quantities called the input values, the what? And the output values, the what? Input and output values. Okay. So it says a function is a relationship in which each input has exactly one output. I'm going to put stars around this. Let's use a different color, actually. Each input has exactly one output. It says critical thinking. The bolded definition is the most frequently used definition of function, but what does it exactly mean? One of the following tables is not a function. Which one conflicts with the definition? I want you to pause the video and think about which one you think. 2 of these are functions, 1 of them is not. See if you can guess whether A, B, or C is not a function. All right, I can't see what you guessed, but I'm hoping that you said, well, let's go through this. Does each input for A have exactly one output? Are there any numbers here that repeats? Nope. So this is going to be a function. This is, yes, a function. What about number 2? Are there any repeating inputs that go to different outputs over here? Yeah, do you see these 2s? These 2s go to 4, they go to 5. That's a problem. That means it's not a function. You cannot have repeating input values where each input has one. Both these inputs are 2 and they have different outputs. They have 4 and 5. Each input needs one output. 2 goes to 2 different numbers. That's a problem. So this is not a function. And the last one, does each input have one output? We got 11, 12, 13, 14. Yep, 11 has 5, 12 has 5. Is it a problem that these 5s are repeating over here? What do you guys think? Actually, it is not a problem. And let me tell you why. As long as each input doesn't repeat and has one output, that's fine. You could actually have 1, 2, 3, 4 for a table and have 6, 6. That's actually not good. Let's not do 6s. Let's do 8, 8, 8, 8. That's totally fine. This is a function. Okay? But this one's going to be yes over here. Or function. So C is also a function. Even though it has repeating output values, it doesn't matter. The one way to look at a table right away and say, is it a function or not, is look at if there's any repeating input values that go to different numbers than the output values. Okay? All right, synthesis, come up with your own input-output table that is a function. It says hints, or make sure that you don't repeat input values that go to different numbers. Come up with any numbers you want. Get creative. Get creative. So the ones I came up with are, I did 4, 8, 12, 16. I did -1 for all of these. You could also do 1, 2, 3, 4, and do 5, 6, 7, 8. The one that would not work would be something like 1, 1, 3, 5, and you had 10, 15, 20, and 25. This one would not work. This one's fine. This one's fine. You just got to make sure that you have no repeating input values that go to different numbers. Okay? All right, next, the domain of a function is the collection of all inputs, all what? Input or x values, which means the range of a function is a collection of all outputs or y values. Have you guys heard domain and range before? Hopefully you have, but domain is input, range is output. Okay, so let's find the inputs for let's find the domain for this table right here. What numbers do you see in the inputs? I see 13, 9, 8, and 3. What about for outputs? I see 0, 7, and 8. I don't need to repeat numbers if they're there twice, though. That's all you gotta do. So domain is inputs, range is outputs. Just label all the inputs, label all the outputs, and you're good to go. All right, we got 2 more examples to do here. We're gonna do the next example on the next page first, and you guys will try the next one on your own. We're gonna do the harder one first together. All right. So let's go ahead and do this one together. It says make an input-output table for the given function. Use 0.5, 2, 4, and 8 for your domain. All right, so I'm going to use for my domain, I'm going to put 0.5, 2, 4, and 8. And it says make an input-output table. So we're going to take these values, we're going to plug it in for x, and we're going to solve. We're going to come up with what the output values would be if we plug those in. So we're going to do y equals 2 times 0.5 plus 9. Let's simplify that. Okay, do we do 2 times 5 or 5 plus 9 first? What comes first, multiplication or addition? Multiplication comes first. 2 times 0.5, half of 2 is 1 plus 9. And 1 plus 9 is going to equal 10. So the first value, the output, if you plug in 0.5 into this equation right here, you're going to get 10. Let's do one more together, then I'll have you guys try a few on your own. Let's do y equals 2. Let's plug in 2 now. 2, we're plugging in 2 from this input table. Plus 9. All right, what's 2 times? We do 2 times 2 or 2 plus 9 first. In PEMDAS, multiplication comes before addition, right? So 2 times 2 is going to be 4 plus 9. That's going to equal 13. See if you can try the other 2 on your own. We're going to do y equals 2 times 4 plus 9. And we're going to do y equals 2 times 8 plus 9. See if you can figure out these last 2 on your own. Go ahead and give those a try. All right, for 4, we got 2 times 4 is going to be 8. Plus 9 is going to equal 17. Next one we got is 2 times 8, which is 16. Plus 9, which equals 25. And there's your input-output table. All you got to do, take the inputs, plug them in for x, solve for y. Easy peasy. Put y over here, I guess. This is x and y. Okay? Now, try the last problem on your own here. It says get the output y by plugging the input x into the equation and evaluating the problem. Make an input-output table for the given functions. We have y equals 4x plus 1. We're going to plug in these values. So the first one we have is going to be y equals 4 times 0 plus 1. 4 times 0 is 0 plus 1, which equals what? It's 1. Y equals 4 times 1 plus 1. Y equals 4 times 2 plus 1. Y equals 4 times 3 plus 1. Okay, 4 times 1 is 4. Plus 1 is going to equal 5. 4 times 2 is 8. Plus 1 equals 9. 4 times 3 is 12. Plus 1 equals 13. All right, sounds good. I went through that kind of quickly. Hopefully that makes sense. But basically all you got to do is you take your input values, you plug them in for x, and you solve for y over here. Okay? And that's how you get your input and your output. All right, thanks for watching. That's the end of the lesson. I hope you guys have a great day, and make sure to bring your questions to class. And yeah, we'll talk soon. Have a good one.